19. So those block diagrams. In chapter 12, the cue codes are on the test, as well as the phonetic alphabet. Okay, if you could go up on the slide. Nobody there to operate the slide?
What do you do?
Next page.
Spacebar.
The CW short forms are not on, but there's questions about digital modes. And I went through the question bank. There are a lot of questions about procedures, both for HF, CW, and for repeaters. And it's really not that hard. It's not like theoretical information. You pretty well just have to read that chapter on procedures. When you get your license, everybody is a bit camera shy or mic shy. So what you do is you'll listen to other people on the repeater, listen to other people on CW, listen to other people on single sideband, and you will get the kind of rhythm of what they're doing and how they identify, and you just follow along. Now I've got a text which will come on, you know, the procedures, how to do all of these contacts, as we call them QSOs, okay? Okay, when you get the block diagrams, you need to know the purpose of each block. Next slide, please. So what's the purpose of the dummy load? Do you remember that from antennas? Maybe I didn't tell you, so I can let you off the hook. Eh? There's the dummy load right there. And whatever you do, don't call your girlfriend a dummy load. So the dummy load is a fake antenna. It will take the power of the transmitter. I can put 100 watts into that thing, no problem, but it really is not transmitting. So what it's doing is it's preventing interference. So in the old days, these were really essential. They're not essential nowadays, okay? Because they have tuners in these nowadays. You push the button and in about 2 microseconds it will tune. In the old days, you needed a dummy load because you had tube finals, just like Matt had here. And in the tubes, you had to, I'm going to get this wrong, you had to dip the grid, I believe they called it. So it was a real business of, you know, getting the thing really tuned up for the frequency you're on. And so what you were doing while you were tuning was you were creating a signal on the band. Okay. So rather than doing that, you transmit into the dummy load, which is a 50 ohm, you know, resistance, and you know, interference while you're tuning up. But as I say, nowadays you can tune up with just, I'll show you on the rig, you just push it and in 2 microseconds it's tuned. Okay? So, what does the low pass filter do? It allows it allows the low to pass and it blocks the high. So what that means, it's going to, everything above 30 megahertz it's going to block, and below it's going to, so these are used so you don't interfere with television and FM radio and all those other things. So that's why they're there. Nowadays, sorry, it's already built into the rig, a low pass filter. You don't need it as a separate component, although some people have it and want to use it. And you need to know what it does for the test. Okay, what does the SWR bridge do? What does the bridge measure? And what does it tell you?
Standing wave ratio?
Yeah, standing wave ratio, yeah. So it's measuring, somebody's coming?
Reflected power?
It's measuring forward and reflected power. Hi guys. Grab your things. Okay, so it's measuring forward and reflected power. So, and what is that telling you? This is, you know, yes? Well,
how big your signal, how strong your signal is.
Getting close.
How much power is in your antenna?
That's right. How much is going on? It tells you what kind of match you've got to your feed line and your antenna, right? And you want a 1-to-1. match, if at all possible. So remember I showed you the two needles, one is giving you forward power, one is giving you reflected power, and in where they meet in between, that tells you your SWR. You want as low as possible. The higher it is, then it means more power is coming back. And the more power that comes back, it means it's going to fry your transmitter, right? Okay, which you don't want to do. But the modern rigs, if you get the SWR too high, they will automatically cut back the power to save. They've got these fantastic circuits in them nowadays. Okay, so that's what an SWR bridge does, and that's what it tells you. The match of your radio, your transmitter, to your feed line and your antenna. Next slide, please. Okay, oh my God. How did that come so small? Look, it's big on my page. Look. Can you make it bigger?
I can. And continue. It's up to you.
Maybe, Jason, you should go over there and help him out, eh?
No, I mean, go ahead.
Is that all right?
I can destroy it. Now that my glasses on, I can see what I'm doing. All right.
Can you try control? Was it control in the center on the? It won't go, eh?
Maybe drag horizontally and vertically, or no?
Oh, there. Oh, text. There it is.
Okay, good. Thank you much. Okay, now, you know what? Unfortunately, have to know this block diagram for the test. But I shouldn't be negative about this, right? But I want to be. This is not what it is in the radio, in the real world that we use nowadays. This is very old-fashioned. The SWR bridge is not a separate unit as it used to be. It's built right into the radio. It's right here. So don't follow me, but it's right here. Okay. Low-pass filter is built right into the radio. Linear amplifiers are still something you could buy separately, but we don't recommend that you buy a linear amplifier, because as we talked about before, you could get more gain in decibels through a beam antenna than you can get through a linear amplifier. And the linear amplifier is going to take lots of power, and it's because you got so much power, it's going to couple with everything. You're going to be into your neighbor's TV, the telephone, everything. So you're better off with a beam if you think you need more power. The transceiver, okay, and see they have an antenna switch here. Antenna switch is built right into the radio. It has 2 antenna ports. I showed you an antenna switch last time. They give you 5, okay, but most people don't have more than 2 antennas. And then why they did it this way, I do not know. Antenna tuner, and most antennas below 14 megahertz, the 20 meter band, most antennas above. So they only have the antenna tuner working on the antennas below. So it'd be 20, right? The 20 meter band, the 40 meter band, and the 80 meter band. That's where they put the, you want the antenna tuner to work on all frequencies. If you're using a G5RV, you need it on all frequencies. So why they did it this way is beyond me. So you need to memorize this block diagram, unfortunately, and they will ask you questions such as this: what goes in between the SWR bridge and the antenna tuner, the antenna switch? See, that's the kind of question they're going to ask you on the question bank. Okay. They might ask you what is the purpose of the dummy load? What is the purpose of a low pass filter, etc. So that's okay. And there was a question below that. If we can get to it, should look like that. There should be a question below that. Of the components in a HF station, which component would normally be connected closest to the antenna tuner, and the dummy load? You see what I mean? Well, anybody got an idea? If you go back to the diagram, you could figure it out. It's the antenna switch. Okay, so these are the kinds of questions they're going to ask you on the question bank. Okay, next one, please. In an HF station, sorry. In an HF station, the antenna tuner is usually used for matching the transceiver with. So most antennas operating below 14 megahertz. That's just a characteristic of that diagram. That's one question they could ask you. Next question. Of the components in an HF station, which component would be used to match the impedances between the transceiver and the antenna? Oh, 4 isn't there, so what happened to...
It's on the next page.
Oh, okay. Oh, yes,
How do you
it's
go
on the
back?
next page. So which one is it?
Arrow back. Yeah.
Match the impedances. What item is going to do that? No, the bridge is going to measure.
1, 2,
Antenna tuner, yeah. The antenna tuner is going to match the impedances. Okay, moving right along. Okay, this is another diagram that you have to memorize, and it's really not that difficult. The input and output here are. Oh, don't worry about the size. Oh, you did it. Great.
I know how to do it.
Computer. That's the screen. The output is the screen. The input is the keyboard. Right. There's the computer. There's the modem, the transceiver, and the antenna. Well, it's a very simple arrangement. Okay. We don't do it that way. We don't do it that way anymore. But the test, the modem, they're going to talk about a terminal node converter, TNC. And don't get confused by that. The TNC is just the modem. Okay, this is the way we do it nowadays. This is for digital operations. This is the way we do it. So you have a computer screen, a keyboard, a computer, and nowadays we call this an interface. Right? It's not called a terminal node controller, but in the question bank they may use TNC, terminal node controller. And all the terminal node controller is a modem. That's all it is. And everybody knows what modem is, right? What is a modem? Modulator, demodulator? Yeah. So it's converting it from digital to analog, analog to digital. That's what it does. Okay? And the component that does it actually is a sound card. The sound card in your computer does it, but the way they do it nowadays, this has its own sound card. So you don't even use the sound card in the computer. You use the sound card here. And it is going to convert the analog to digital, digital to analog. Okay? So this is called a Signal Link USB, and they make these specifically for each radio. This one is for the Kenwood TS590S. Okay, and I'll talk more about digital motors. Okay, so you need to know this diagram, and as you can see, it's really very simple. Obviously, what are you going to connect the antenna to but the transceiver? You have your interface, and the interface goes to the computer. So that's pretty straightforward. Okay, and if at the bottom of the page, it gives you a little more explanation. It's possible. I had to draw these diagrams myself, so I hope you appreciate all my hard work. Okay, so it's just what I said. Yeah, okay. So everybody should have that down pat. Next slide, please. Now this part is not on the test. Before you go buying equipment and spending thousands of dollars, get the advice from somebody. Okay, talk to people. If you come to our social events, our club meetings, our Sunday meeting at McDonald, pigeonhole a guy and say, what do you have? What do you think would be good for me? This is what I'd like to try and do. Okay, and have you bought this rig? Have you had trouble with this radio? Okay, that's one way of getting some information. And you should read online reviews. So if you go control click, we should get that control click. We should get this the reviews. eham.net. There we go. Should go right to eham.net. So this is what the reviews look like. You want to open that page up, make it big? There we go. Okay, and see, you can get them on any subject. If you can scroll down, and you'll see somewhere we're going to get to, okay, here we go. Transceivers, base mobile, click that one. Oh, yeah, click that one right there. Yeah, you got it. And see what we get. Okay, so here's a list of all of them. Scroll down here, see if we can find mine. You were looking for Kenwood. I-J-K, keep going. Kenwood, okay. Kenwood. Okay, these are some weird numbers here. But anyway, let's say, yeah, let's pick one of these. Okay, so it'll only one review on it. It's an older radio, and only one review on it. But if we got to my radio, you'd probably find 20 reviews on it. So that just gives you an idea. Okay, let's go to the next. Get out of there. Okay, download the manual before you buy the radio. Okay, very important. Even if you print it out on your own and you waste a lot of paper, it's better to have the manual first. Gives you an idea what you're going to be doing when you get the radio, rather than getting the manual after you buy the radio and getting something like that to read, right? This is a lot of manual for the IC 7100. It's HF, D star, and everything built into it. Now, to be fair, this is the advanced manual. They also make a basic manual, which is about that big. But still a lot in comparison to this, which is the Kenwood manual. You could print out yourself, and you see it's a lot simpler, this manual. So getting a manual is really helpful in determining whether or not you're going to buy the radio. The difference between this radio and this radio is that everything in this radio here it's not menu driven. It's all controlled by the knobs. Everything is on the front panel. Okay, some of it is hidden in features inside in menu driven things, but you set them once and that's it. You never have to touch them again. A radio like this, you're always going into the menu to click on a feature that you want. It's not always up front on the knobs that you want. It's called a menu-driven radio, so you're always in the menu to select features that you want. With this radio, no. So this radio, I shouldn't be plugging Kenwood, but I love it, and it's a lot easier to use than some of these menu-driven radios. But hey, some people love that kind of radio, and it will do a lot more. It has a lot more features on it as well. So now, where are we? Okay, and there's a download there. See if you can download that. Control whatever. Open, please.
Where?
Okay.
Okay.
Oh. Okay.
It's hard to see. I know. I couldn't do it from there.
I got my glasses on. I still couldn't see.
Oh, it's too much.
Hit the flashing icon down at the bottom. The Explorer. Yeah.
Oh, what did you do?
There it is.
Yep.
Is that it?
You just gotta click on it
There.
and then click on that one.
Okay, so now open this up big. Yeah, and you see there's the manual right on the internet, and you can download it. Yeah, keep going, and we'll show you the front of the of the transceiver. Should be there somewhere.
Made by JVC?
Yeah, same company.
I didn't know that.
Yeah. Now you see, what I'm also saying is, yeah, keep going. That we can't give you a hands-on course on these radios, because they do have similar features, but they're all basically different. Yeah, keep going.
Where did you want to go?
I want to go to the okay, see, it's showing you here how to hook it up. It's giving you ideas on how to hook it up. Okay, keep going. Yeah, okay, keep going. It'll show you connections, how to connect it. Yeah. Keep going. Installation. Yeah, okay, here it's showing you how to connect the power supply, which is essentially the power supply, that cable going here. Okay, keep going. Okay. Now it'll show you how to change the fuse. Keep going. And see here, it shows you how to connect everything and what all the connections do. Yeah, where to put the mic, where to put the speakers, where to put the key. It'll have the key in a minute. See, here's the key coming up.
Like, none of this comes with the radio, right? You have to buy the mic.
The mic comes with the radio. The speakers don't. The key doesn't.
Just the basic mic, not the one you use? Or?
Yeah, the basic mic comes with it, and there they're showing you the keys and where they connect and how you're supposed to hook them up.
And you have to get a power supply now.
Yeah. Okay, and then okay, stop right there. Okay, so now we're going to get into, I believe we're going to get into the radio. If I know what I'm doing. Okay. Oh, yeah, that's where my page is. So, as we said, you got to get the radio, and then you're going to do it just like when you first learn how to use a computer. You're going to read the manual, and then you're going to push all the buttons, and you're going to see what happens, and you're going to experiment. That's the only really way to learn, okay? And I can tell you how to do this radio. If you bought one of those, I'll show you how to use it. But you might buy an ICOM or a Yaesu or whatever, and there's all different models that you might buy, and I won't know how to use that because I haven't read the manual and I haven't played with all the buttons. Okay, so that's something you're going to be doing yourself. Now, this is the front panel of the radio, and this is a very important button here. It's audio frequency and RF frequency. So that's the volume control. And the RF is the signal that's coming in from the air, and it's adjusting the amount of amplification right from the antenna. Okay, that's what that one does. It's very important. This one here, there's two knobs in this set. These is high shift and low width. So what it does, these are your filters, and what the filters do is they bring the passband of the receiver, they can close it or open it, right? So they can make the amount, what it's receiving, narrower, so it's like a narrow filter, so any interference would be coming out. And then what you can do is you can shift it. So you get it really narrow, and you could shift it one way or the other to get rid of the interference, okay? Because usually, especially you work contests, there's a lot of, there can be a lot of interference. So that's a really neat feature, and it will show up here on the radio. It'll show you the filter width, and it'll show you it shifting, okay? Now this feature, Squelch, you would use Squelch on FM 10 meters, let's say, or 6 meters, but normally Squelch is not used. But this is a neat feature, and it's a notch filter. And what it does, if you got your signal that you're listening to and there's another signal close by, this is a very sharp little filter. You tune it right to that notch and it takes it out. It's a very neat feature. CW Tune it has a feature. It's sometimes hard to tune CW. You push that button and it tunes it. It moves the radio and boom, it tunes it right to that frequency. Only problem is if you got 3 or 4, if you've got this signal and there's one close that's really strong, it'll tune it to the strongest one, unfortunately. So that is a problem, but it's something you can get used to.
What does CW stand for?
Morse code, continuous waves.
Okay, all right.
Okay, people say, why are you talking about continuous waves? Because it's broken up. Yes, well, it's that it's not modulated. There's no modulation there. It's just the transmitter's going on, 100 watts is going out, transmitter's going off. So there's no information or intelligence that's put on that signal as you do with AM, FM, and all the others. So it's called continuous wave because that's all that it is a wave, not modulated. Okay, now I don't use these very much. These are memory. You could put all kinds of memory. You could memorize all kinds of channels, everything that you want, any frequency that you want can be. So you meet with somebody on 7.022. You could put that in, right? And then you can recall it here, so it comes up. You don't have to tune to it, okay? So that's what a lot of this is for. These buttons here allow you to record a Morse code signal. So I can record my call, CQ, whatever, and just push the button and it'll send it out. I don't have to use the key. See? So you can be really lazy if you want.
So your introductory of yourself?
Yeah, you can do it in, yeah. Now they also do, not voice though, Morse code.
Right.
They also have a module that you could buy for blind people with this radio. And, you know, when you hit a button, it'll tell you what the button is in voice. Okay, so that's another feature that's available. These are the different modes, you see, lower sideband, upper sideband, CW, Morse code, FSK, frequency shift keying, we're going to talk about, that's digital modes, AM, FM, data, and to tell you the truth, I never use that, and fine. The fine is whether you want fine tuning or rough tuning. This is your entry pad here, and if you just push this, you'll get to 160, push that, you're on 80. But if you push the entry, then you'd have to put the number in of the frequency that you want, right? So you put enter, and then the screen will go blank, and then you put in 10110, enter. Okay, or if you wanted that 30-meter band, you just go boom, right? So this allows you to either put the exact frequency in, or just go to the band. Okay, key. This will give you your key speed. That's the general service band, which 60 meters, which I don't use very much. 50 is of course the 6-meter band. There's your mic. There's your phone. This will transmit, but most of the time we don't use that button because you've got to push to talk on your mic, and in Morse code you push the Vox, the little signal will come up here, and as soon as you hit the key, you're transmitting. Now this radio has a very nice feature. It gives you these buttons here, this button and this button, and you can move things around on those buttons. Also, if you buy a more expensive mic, you can put things on the mic. So I put this button here. I moved it. It's still there, but I can move it to there. So that allows me, in a thing called split mode, more about that later, in split mode it allows me to check the split. I put this button here, that's CW tune. So I hit that button and I can tune with CW. Okay, so that's just one of the features. You'll find all about this when you eventually buy the radio. Okay, let's.
Just a quick question.
Yes.
Does it operate I mean, I've never done it before. Does it operate more like a chat room or a telephone call? Like, do you have to know who you're talking to? Like, I know you can eavesdrop on conversations.
Yes.
But are they direct conversations that you're eavesdropping, or like if I want to talk to LA, am I listening to everybody in LA like a chat room more than?
There could be more than one listening on it. You never will know that.
Unless they're actively participating?
Yeah. So what you normally do is you would call, right? You would say, and we'll get into this, you would say CQ, this is whatever your call is going to be, VA3ZB, calling CQ, 20-meter phone, let's say.
So do these act like a radio where you can scan?
Yes.
For an
Yeah,
open
there's a
line?
scan feature in here too. I don't tend to use scan, but yes, you can scan.
Okay.
Yeah, it's in there somewhere.
Just to see if you get a random.
Yeah. Well, so what normally I do is I tune through the band, right? You just tune with the main tuning knob, and then you hear somebody,
Can you stop reading a little?
and he's saying, there you go.
This is what you'll hear.
He's tuning.
I'm actually tuning an HF radio somewhere in the world right now. And I'm actually on, I'm on 40 meters right now.
40 meters.
But this is what it sounds like until you find somebody. I think this one, the one I'm controlling now is over in actually in, they're actually
There's
in
code
Morse
there.
code now. And this is actually over in, I believe it's over in Europe somewhere.
So you, at this point, would slow down your tune.
Yeah.
And then.
Then you listen to him,
Yeah.
and then you see what he's doing, right? And he could be saying, he could be talking to another guy. So you can't interfere with him right away, right? You don't want to do that,
You block this thing.
because then you're creating a problem. So you listen and hear what he's doing, and if he's calling CQ, see, he's asking for anybody to come back to him. So then what you do is you come back to him, you got his call, you write his call down, so you say DR5NB, this is VA3ZB, over.
Yeah, and then you
See,
check.
then he comes back, and then he says VA3ZB, this is DR5NB, good evening, old man, you're 559 in Dusseldorf. Say, this is how it goes. Now somebody can break into that conversation, and then you got a threesome,
Yeah.
right?
Those can get messy.
It can, yeah, and the other thing we do is we have nets, and a net on HF, we also have them on 2 meters. What a net does is he puts out a general call. There's one at 9 o'clock every night on our repeater. Put out a general call for amateurs to check in, and then they check in one at a time. They give their call, and then the net controller says, okay, VA3ZB, please come in, and you have a turn, you talk to the net controller, he says whatever, and fine Bruce, and he goes to the next one, then when that's finished, he says more calls, people check in please, and we do that on 2 meters, analog and digital, but it's also, you also do it on HF.
So there's no policing of this either, right? Like, in theory, you could go in there and pretend to be somebody else.
Yes, but
I'm not saying they do. I'm just,
yeah, but people can do that, and we call those bootleggers, eh?
okay.
Because they don't have a license. And then what happens is radio amateurs like you and I get together, and we triangulate him with the beam, and we find out who he is,
Oh,
right?
okay.
And eventually he's going to be closed down. We put enough pressure on those kind of people that they would get closed down. But most people are so proud of their call and proud of the work that they've done to get it, and especially when you're on CW, it's a lot of work to get it, right? That they don't want to get on there and goof up,
Right.
you know? Okay, so let's go to the radio itself. Is that going to be possible?
What's it saying there?
Yeah, click the highlighted one. Yeah.
There you go. Thank you.
One more.
Is there any companies in North America
She
that
pulled
make
the
it now,
stick.
or is it all
Um,
like ABC and
They're all
Hold
Japan.
the plug.
Japan?
That-
They're all
pulled the
they're all
plug.
Japan, yeah.
She didn't wait for me to close down properly. She just pulled the plug.
Okay. I might get down on my knees here to Well, I could start with the power supply. I'll start with the power supply. This is a 35 watt Astron power supply, and it's the old style with the transformer in it. A lot of amateurs insisted on having this type of power supply because of the because it's heavy. It's got a great transformer in it. It's not going to create interference. We were always concerned about the other power supplies, the switching power supplies, that they would create interference on the radio band. So as you were tuning through it, interference would be coming from your power supply. They've got the switching power supplies so good now that Bill Moss, who took the course last time, I was fooling around with his, and we couldn't detect any interference coming from the power supply. I like to have the needles on them, the meters, because it'll tell you what your voltage is and what your amperage is. So when you key it, let's see if when I key it, okay, you should see the needle go up. Yeah, it tells you how many amps it's pulling there. Okay, so that's the power supply. This is the HF rig, and the Kenwood TS590S, and it has a number of great features, as I was pointing out to you. Okay, it's operating on split now. Take the split off. I don't know if you saw. Okay, one of the things this radio will do, it knows what part of the band is on CW, and it will automatically put it on CW. When I get up to the portion where you see it switched automatically to lower sideband, you can program that into the radio. So I'm going to go back to CW, somewhere around here. Shouldn't be any signal, because it's on a dummy load. And the notch is on. I took the notch. Okay, I'll just show you the antenna tuner and how fast it tunes. That's it, tuned. You don't really need a dummy load. It's just in a microsecond. It sends up 5 watts, and it uses that to tune it. Okay. Let me see. What else can we show you? This is the main tuning knob. Oh, I was going to show you the. This is your filter, and it's completely opened, and I can reduce it. See how it changed the sound? And I can switch it. Switch it from one to the other, one side to the other, to avoid interference. Now let's see. Now if you watch as I transmit, you'll see it'll tell you how much power is going in. So it tells you right here it's 100 watts, and it tells you down here the SWR. It says it's on the 1, so telling you the SWR is 1 to 1 into that dummy load.
That's because it is a dummy load, though, right?
Yeah.
If you had a 4 antenna, it could be much higher.
It could be much higher, but I just hit this, antenna tune. In a couple of seconds, it'll tune it. Let's try another band. Here's the. Well, let's go a little faster. There's the 20 meter band. Now watch, we'll tune it. You'll see how fast it is. There it is. Tuned it. Fast. So yes. You can also, the meter has different functions. You can watch your automatic limiting control, SWR, etc. Okay. Has a preamp on it, attenuator, all kinds of fancy things that you're going to learn about. Now, with SignalLink connects to the there's a data port in the back of the radio, Signal link collects to that. This one goes to your computer, and then you have a program on the computer, and you run PSK31. That's what most of us use. And with that, you type on the computer screen, right? And it converts the digital into an analog signal that goes out through the antenna, and the other guy, it does the reverse. So he sees it on his screen, your signal, and you type, and he types, and you have a nice conversation. It's called PSK31. So that's another, it's HF digital. That's another mode that you can use. This is the...
is it like using Morse code?
No, it's actually done just through typing.
Just typing.
Done just through typing on HF. Now the advantage of it is it only uses 25 watts, and it's only 31 hertz wide. So it's a great mode. Morse code is 800 hertz. So that's something to keep in mind. It's a great mode. This is a 2 meter. This is the 2 meter mobile. It's probably the kind of radio you will get and put in your car.
Yeah.
Okay, and it's on our repeater here. But before we make any big boo-boos, we can plug in an antenna. Okay, now if you watch this, okay, it's on 14694, which is our club repeater, right? But when I go to transmit, see what it did? It shifted to 16340, a negative 600 kilohertz shift. Okay, so it transmits on one frequency, receives on another. Okay, so this is how repeaters work. It picks up the signal, retransmits it. So this way you get greater coverage than just this little radio will do on its own. The handhelds work on the same basis, but I doubt very much you're going to get anything here.
You got to program that offset into the radio then?
A program?
You got to program that offset in there?
You got to program the offset, but in the new radios, you put in a cable, and you program all of that via the computer. It interlinks with the computer, and you put all that stuff in, all the offsets and everything is put in. This one also has a tone on it, so it transmits a specific tone, 107.2 hertz, I believe. And what that does is that will make the repeater work. Without that tone, the repeater won't work. It needs to hear that in order to open up. So it's a way of functioning a little better with the repeater. Okay, so I think we can come back now to this. I won't go back there, but I can show you more of that later if you're interested. Okay, go to the next slide if we can. Yeah, okay, and then and the next one. Okay, this is also not on the test, but I wanted to make sure that you get this. I sent this to all of you by email, okay, and I wanted to make sure you got this. These are the three types of G5RVs, the regular, the long, and the junior. The regular covers everything from 80 to 10, the long covers everything 160 to 10, and the junior covers the 40 meter band to 10. And here are the lengths of the elements in feet and in meters, okay? So next slide, please. Okay, we talked about this before. The twin lead that comes down the matching session must stand off at least a foot from any metal objects, metal flashing, etc. You can make the antenna into an inverted V, and the legs can be all bent around if you need to get into the property. Next slide, please. You need the antenna tuner to make this work on all bands. It actually is designed, it's most resonant on the 20-meter band, but it'll work on almost any band. And these transceivers now with the antenna tuners in them, they will tune a 3 or 4 to 1 and bring it to a 1 to 1. So it's going to work marvelously. The elements on the G5RV must be of equal length, and if they're not, use a choke. It's recommended that you use a choke, which is simply winding up. You'll get instructions on this of winding up the coax cable 6 or 7 turns, about that big, and just taping it up. That creates high impedance so that the RF will not get on the braid. Next slide, please. Yeah, there you go. Okay, next slide. Q codes. Okay, could we bring that up a little? It's
Next slide.
it's only giving 1/2 of it. Okay.
I keep hitting it and keep getting it.
If you zoom out, you might be able to get more on a page.
Okay.
Bottom corner, it's at 300%.
Here?
Yep.
Yeah.
down.
Yeah. Go that. Yeah. There.
Is that helping?
Okay. Well, yeah. There. It's going to be a little too small to see, and it's kind of screwed it up. Okay.
Whoops. There you go.
Okay. It's screwed it up, but that's okay.
It now matches the sheet that you have.
Yeah. No, it doesn't. See.
Oh.
Oh, it's
matches.
because it's landscape versus portrait.
Yeah.
Yeah. Oh, it won't go. You can't convert it back to portrait.
You can't. The TV's landscape.
Oh, I see. Okay. Well, the Q codes are on the test, and so you need to memorize them. The Q codes are used in CW, but they're used a lot in single sideband voice communications as well. Okay, there's an affirmation. I don't know, we can't even see. There's an affirmation and interrogation. And what that means, it's the same Q code, but one you ask, you just make a statement, and the other one you're asking a question. So I'll do it for my sheet because this is not the best. QRL without the question mark. QRL in Morse code means do not interfere. Okay. QRL question mark means is this frequency busy? So in Morse code, that's the first thing that you would give. QRL question mark. Is this frequency busy? QRM. The M means man-made. QRM means man-made interference. So if I say QRM, I'm saying I am experiencing interference. If I say QRM question mark, I'm asking, are you experiencing interference? Okay, that's interference from another station. QRN, the N stands for natural. Okay, so that's static, that's some kind of natural noise. So here again, QRN, I am experiencing static or noise. QRN question mark, are you experiencing static or noise? QSB, QSB is my signal is fading. QSB question mark, are your signals fading? Is what that means. QSY is change frequency, or shall I change frequency, with the question mark. QSL is acknowledge. That's send letter is what you usually learn that by, send letter. QSL, when they say it on the radio, they actually mean I acknowledge, I confirm. QSL. QRV means I am ready. QRU, I have nothing for you. In other words, I want to end the communication. QSO is what we normally call the contact. Okay, we are having a QSO, we're having a contact, a conversation. If you put the question mark there, it means can you contact? So QSO question mark VA3ZE, can you contact VA3ZB? QTH, this is used in sideband as well. QTH, my QTH is Sault Ste. Marie. QTH question mark, what is your location? QRZ, you are being called by. Many times you're transmitting and somebody's on there, and you can't really hear them, so you say QRZ question mark. Who is calling me? And that's a cue to the fellow to say give his call, and he will usually say D, which is from whatever. Okay, QSK. It could be on the test. I can hear you between my signals. Okay, in Morse code, there's the signal and there's a space, right? And actually, if somebody else was on there, you could hear them in between the spaces. Okay, so that's what the QSK is referring to, and the radio can actually be set in such a manner that you will hear it in between the spaces. Okay, that's what QSK is referring to. QRO is increase your power. So somebody might say, could you please increase your power? Or shall I increase my power? QRP is decrease your power. And many people, that becomes a hobby as well. QRP is a hobby where people transmit with 5 watts and under. Okay, and they try to make worldwide communication with that. So there's a QRP hobby, and sometimes you'll see a station VA3ZB/QRP. That tells you right off the bat that this is a low power station, right? A lot of people love that because you can make your own equipment. You can make it very cheap. You can go in the bush, throw up a little antenna, and you got a little 2-watt transmitter, and you're going for it. Okay. QRQ send faster. That's never used in sideband. QRS send slower. QRT stop sending. Or sometimes you would say that station is QRT, means he is stop sending. Okay, the typical short forms, we've got some here. These are not going to be on the test. Okay, this is just for your information. But some of them are used in sideband. 73 is best regards. A woman would say 88 hugs and kisses, which is kind of nice. Old man, old boy, old man, it's used in sideband. Okay, so when you call somebody, he's on the air, they'll say you're 599, old man. So that's the typical way we talk to each other. Okay, Roger is used. Roger is just R in Morse code, but it means the confirmation. Just like QSL means confirmation, but Roger also means confirmation. So you'll hear guys on the radio say, Roger, Roger, you're 599, Roger, Roger. Okay, so most of these are not used. These won't be on the test, but these are used in the digital mode, in PSK 31. They're used in the digital mode as well. Okay, next slide. Okay. Unfortunately, you're just going to have to memorize this. Alpha, Bravo, Charlie, Delta, Echo, Foxtrot, Golf, Hotel, India. You need to memorize it, unfortunately, or fortunately, as the case may be. And I wish you would memorize it. And the reason is you get a lot of amateurs on the radio band that don't use it. And it's very unfortunate because when they don't use it, you don't know what the heck they're saying. So they'll say, my call is Victor Alphabet Broadbean 0, and it just is, it's just, it's the International Phonetic Alphabet. This is what we should use. Okay, it makes life a lot simpler. The reason you have to use it on HF is because it's not always clear what the fellow is saying, especially if he has an accent. So you've got to slow him down and get him to do it in phonetics. As soon as he has difficulty, go to the phonetics. That's the answer. Okay. Okay. So if you're doing a contact on Morse code, you check first that the frequency is clear. And so what you send in Morse code is QRL. The first thing, you tune up and you go QRL question mark. Is this frequency busy? You do the same thing on sideband. Okay? You don't hear anybody, but just to be sure, is this frequency busy? And if nobody comes back, and you get there first, the frequency is yours to use. The rule is nobody owns the frequency. Nobody. Whoever is there first, and it's clear, can use it. So, once it's clear, you call. 3 times, this is recommended, 3 times CQ and 3 times your call. AR is end of transmission. And you repeat that until you get somebody. Question? Somebody had a question? No. Okay. You repeat that till you get somebody. So on sideband it would be CQ, CQ, hello CQ. This is Victor Alpha number 3, Zulu Bravo. You can use the phonetics if you want. VA3ZB, VA3ZB. And in sideband you usually say over. And then you wait for somebody to come back. Okay? If he comes back, this is what it's going to be. VA3ZB, he's got your call. VA3WMZ. Over. At this point, the communication has been established. With the exchange of the calls, communication has been established. That's it. It doesn't have to go farther than that unless you want it to. The reason for that is all of those calls are listed on QRZ. You can look them up. You will know who you're talking to, his street address, where he lives, etc., etc., etc. So you really don't need more than his call to know who's talking to you. The station that calls first has the frequency, not the one who answers. So the frequency belongs to VA3ZB. So the other, when the conversation is over, the other guy leaves. The other guy doesn't have that frequency. He leaves. It's still mine, unless I relinquish it. Next slide, please. Okay, information. The information you give is RST, readability, strength, and tone, on a scale from 1 to 5, 1 to 9, and 1 to 9. You give your name, the operator, or old man, and you give your QTH. That's the usual exchange of information that most amateurs give, and they give it right at the beginning. Readability, strength, and tone. Readability is on a scale from 1 to 5. How good is it? Can I really understand what he's saying? Okay, if it's a 1, yeah, if it's a 5, means you can really hear him. If it's a 3, it's sort of dicey. Okay, strength is what you're getting on your S meter. If the S meter is going up to 9, then that's what you would give him. The tone is only used for Morse code, and really the tone is all good nowadays because it's all factory made equipment. Tone's not going to be bad, but in the old days tone used to be bad. Yes?
That was on the test. That was a test.
Yeah, that'll be on the test. Yeah. Okay, so in sideband you wouldn't give you only give 5/9. You wouldn't give 599 because it's not Morse code. Okay, and you just respond with the data the calling station provides. If he only sends the RST, then only reply with the RST. Don't give him all the other information. He says, VA3ZB, you are 599. Then only send him what his signal report is, 599. That's it. Don't send him anything else because he wants to make more communications. He just wants it short, right? Because he's most likely a DX station. But if he starts getting into 599, I'm using the weather is this, that, he wants to chat. So then you can have a chat. Okay? You can have your chat. And at some point, you want to identify at each over. Yes, don't forget that. You want to identify. The regulations say every half hour. I believe you should identify every time you pass it back to him. Okay? Or he passes it back to you. The CW excuse. The ultimate excuse is QRU. I have nothing further for you. But there's a million excuses, like my wife just called, the telephone is ringing. Usually you give an excuse, and then in CW you end it. Now we're going to end it here, and we didn't get through we didn't get through all of this, but I have sent all this information to you. So I suggest that you read it over, because there are a number of questions on procedures on the test. Also, you should understand how you use a repeater. Repeaters are different. You don't give signal reports on repeaters. And when you want to get in an emergency communication, a repeater, you would say break, which you don't usually do in HF. So all that information is written out for you. PSK 31, I didn't get into that. And radio, teletype, and telegraph. There's a fair amount of questions about PSK. And I've given you, if you have this at home, you've got a short form of this at home, a short form of the chapter that you should take a look at. This business on split operations, not on the test, but if you get a radio and you want to operate split, that means you transmit on one frequency, receive on another. That will explain how to do it. Any questions? That was a kind of quick to cram 2 chapters in and get you a look at the radio. No questions? Time for break? Don't forget the donuts.